Okay, students, now we'll talk about center of mass, which is page 283 and the next pages. I think you saw the video which talk about the meaning of center of mass. It is easy to derive the formulas. How can we find the position of x and y for the center of mass? Let us start in one dimension in x direction. Now, if we have two masses, simply m1 and m2, the position of m1 is x1, the position of m2 is x2. We need to assume that they have a position of center of mass for them. And we will see later that this center of mass will be closer to the larger mass. And at this point, the system seemed to appear that all the masses is centered at this point. Okay. Now, if we derive it in this way, x, the position for center of mass, x center of mass multiplied by the total mass m1 plus m2, m1 plus m2 is equal to m1 multiplied by its position, m1 x1, plus m2 multiplied by its position, which is from the origin x2. We can divide by m1 plus m2 this way. So x center of mass will be equal to m1 x1 plus x2 m2 over m1 plus m2. We need to be to know that m1 plus m2 is m capital, which is the total mass of the system. Okay. If we need to go to y direction now, it is the same. If we have two masses, m1 and m2, this is the origin. We have y1 for m1, y2 for m2, and this is y center of mass. Simply, y center of mass is equal to y1 m1 plus y2 m2 over the total summation of all the masses in this system, which is m1 plus m2. It is the same as x formula, but we need to use the x position and the y position for the same masses. What if we go to two directions, x and y plane, and more than one mass? If we have the first mass with its position x1, y1, the second mass with its position x2, y2, third mass with x3, y3, and fourth mass at x4, y4, and we can put any mass we want with known positions. Okay. If we need to find x center of mass, the x position of center of mass, okay, how can we find that? Just m1 x1 plus m2 x2 plus m3 x3 and so on. If we have more masses, we can put them divided on the summation of all masses, m1 plus m2, m3, m4, and so on. So we can put x center of mass is equal to summation of masses multiplied by its x position, because we are talking about the x position of center of mass, divided on m capital. M capital is the mass of all the masses of the system. Okay. And that's it. For y center of mass, it's the same, m1 y1, m2 y2, m3, and so on, divided on m1 plus m2, m3, which is m capital, the same m capital. So y center of mass is equal to summation of the masses multiplied by each mass multiplied by its y position, divided on m capital. It is simple. This is y center of mass, this is x center of mass. Let us now look at this example. We don't need to draw xy plane. It is just numbers. Okay. If we have three masses, m1 5 kilograms, m2 20 kilograms, m3 is 1 kilogram. The position for M1 is x1 y1 3 2, put x2 y2 0 7, 10 10, which is x3 y3. Okay, find the point of center of mass of this system of bodies. Okay, x center of mass, it is simply m1 x1 plus m2 x2 plus m3 x3. We have just three masses and their positions are known, x1 x2 x3, divided on m1 plus m2 plus m3. Just we need to put the numerical values, which is the mass 1 is 5, mass 2 is 20, mass 3 is 1, and their positions in x direction 3 0 10, 3 0 10, and the total mass is 5 plus 20 plus 1, which is 26. Now the total value is 25 over 26, which is 0.96 unit in length unit. Maybe it's in meters or in centimeters or kilometers and so on. Now, y center of mass, it's the same. M1y1 plus M2y2 plus M3y3 over the total mass. The total mass, it's the same, 26. Each mass multiplied by its y position, it will be altogether 160 divided by capital M. This will be equal to 6.15 unit length. Okay, now we find x center of mass and y center of mass. So xy plane, xy point, position for center of mass is 0.96 and in x direction and 6.15 in y direction, unit of length. Okay, maybe in meters, maybe in centimeters and so on. This is simply how we can find x center of mass and y center of mass. Maybe everything is known, but the mass number 3 is unknown. We can't find it. If everything is known, we need just one parameter unknown and then we can find it. Okay, thank you.